I hope my screen is visible.
Yes, sir.
So we are discussing the GS6 means the week 6 content, and the week 6 content, the deadline you can see it on 13 July, and it is pretty easy. So this thing we will cover. Most of these things and the geospatial part I will cover in this session, and the SQL part will be covered by Jivraj in tomorrow's session. Okay, so let us forward for the first important thing. The first important thing is the correlation. Yes, Lovepreet.
Sir, I don't see the module 6 in the TDS.
Module 6. This here is the link of the graded assignment.
Okay,
This
so
course.
it will not be updated in like the dashboard.
You can do it from here, and you can just change the URL here also. If you want GA5, so this will be GA5. If you want GA6, this will be GA6.
Okay, all right. Thank you.
Okay. Just wait a minute. Yeah. So this is the correlation, and the correlation is generally represented by this. So this is between two variables, and we say that it is the covariance of x y divided by a constant. They are standard deviations, but this is the main thing, no? Magnitudes and signs are generally this thing. This thing, okay, this value can be any real number, but this value will be -1. Okay, let us understand this covariance first. So this covariance is generally, if you have remember the formula from stats 1, it is sigma xi minus x mean. Okay, yi minus y. So this is the covariance formula divided by n or n minus 1, something like that. Okay. So just understand the point. What is this? This is the difference of each data point from its mean. This is also difference of each data point from its mean. So if this x variable is less than xi, and if y variable is also less than y mean, then this will also be negative, this will also be negative. And if both are multiplied, the covariance will be positive. And if both are positive, means greater than, then if both things are multiplied, the value will be positive itself. Okay. Okay. So the positive, this -1, 0, and 1. Okay. This positive range come when both are less than their means. Okay. And this negative range will similarly come when one is greater than its range and another is less than its mean, or the vice versa. Okay, there could be interchange. So it means if one value is constantly decreasing, constantly increasing, then other value is constantly increasing. So this is the thing. If x increases, then y increases. If x decreases, then y decreases. Similarly, here it represents if x increases, y decreases, and vice versa. Okay, so this is what the correlation represents. Yes, Lovepreet. Uh, okay. Okay, so let us first understand the correlation. Okay, so this is one correlation thing. So before going forward here, suppose I have x and here I have y. If I have these values, okay, then if I and here the suppose the values are 2, 3, 4, 5, 6, 7, 8. Here the value is 7, 8, 9, and 10. Any value. Okay. So you can easily calculate the correlation using the formula correlation. The formula is CORREL, and here you can provide the array one. This is the x variable. Okay, and this is the y variable. Okay, so this is giving a very strong means this one increases it this one increases, but suppose this one increases too much. Okay, so these values are increasing too much. It means the variability is 0.98, the correlation. Okay, so this correlation represent that. Suppose you have these data means other variable like x2. Okay, here also some values are there. So how to calculate the this is the correlation between x and y. Okay, if you want to calculate the variability between x2 and x, then again you need to write this CORREL function, and yeah, the CORREL function, and you need to provide the x2 and x. So this is giving a negative, means as this value got increased, the value got decreased. That is the point, or there is a weak relation because this is 0.3. It is near to 0. 0 means there is they are random. So you can see clearly that there is very weak relationship. They are random. Okay. But if you want to calculate the correlation between each pair, so what you can do, you can go to the data tab, and here the data analysis is there, and go to the covariance or correlation. Okay, and here just select the things. So I am selecting labels also from here. Okay, the label is also selected here. You need to then check box that labels are in there in first row. Okay, here you can specify the output range, and I want the output to be here. Okay, just I will select this field, any random, and here you can see the output is visible, the same value, the x2 and x. Okay, the same value is also present here. Am I audible?
Yes, sir.
Yeah, so this is the x2
Can you
and this
show
is
the
the,
steps again?
yeah, okay. So I need to calculate the the value between the correlation. So I will go to the data tab. There is data analysis. I will go to the correlation. So there are this one field and this one field. Okay. So here what I did, let me remove everything. Okay. Here input range I want to. So I am selecting this whole range. Okay. And since in the first row has to be neglected because the first row has the uh, labels. So here you need to check the labels. Okay. Then here you can provide the where you want the output. I want the output to be here itself. So I will select this first cell. Okay. And then if I click on OK, I am getting the correlation here.
Okay, sir. Understood.
Okay. Okay. So this was the correlation thing. Now the next important thing is the linear regression and p-values regression is there.
Take just one sec. How did you open the dialog box from the formula itself or through the formula, that fx symbol?
Which one?
The dialog box for in which you were entering. Okay.
Image, sorry.
No. The correlation pop-up, the modal which was open. Using
Here, if you go to the data tab, there is data analysis.
Okay.
In
Can
my
you-
screen is lagging.
No, I missed this part in which you opened the. So I waited for you to explain, and then I asked.
Okay. Okay, I hope you get them. Okay, let us move to the other
Sir,
things.
excuse me.
Yeah.
Sir, on my Excel, I don't find the data analysis, sir. Do I need to install anything?
Yeah, there is add-on you need to install. Okay. Let me
Okay,
tell you.
thank you.
So you need to go to here files, and there is options. Okay.
Yeah.
Then there
Yeah.
is add-ins. You can see
Okay.
I have installed the analysis tool pack.
Okay, sir.
Okay, other tools here at the bottom are mentioned. You can install.
Okay, sir. Thank you, sir.
Okay, so there is a regression I want to cover next. P-value is R square. But why these all things needed? Let us understand this. What is regression? I hope you all already know. Okay. So if I ask you what is regression, then you might say that it is just a prediction of real numbers. Okay. But there is something more. Suppose I have an x value, then there is I have a y value. Okay. Or suppose I have yeah, just now I have x values are as follows, and the y value depend on x. Okay, the y value depend on x. Uh, there is a slow there is a 2 times this first value plus 10. Okay, so y value depend on it. So if I draw a straight line graph between them, we have to look, yeah, insert I want to insert a scattered graph. I think this one will work. No, it is not working. Yeah, line chart. So the data range will be on. Yeah, here is the, I think, scattered chart. Why it is not insert the
You have to select the data set first, right?
yeah, maybe I need to select the data set first.
Then click on insert, and then it will populate.
Yeah, you can see here it is a clear straight line. Okay. So definitely, what will be the value of next data set? Can you predict the value of next data set? If the value is 10, then the value will be 10. into 2 plus 10. So it will be 30. Yeah, the same thing is done by the regression also. Okay, the same thing is done by the regression also. What I will do, I will go to the data tab again, and I will go to the data analysis, and there is regression option you can see. If I go to the regression, there is input x range and input y range. So the y range, the predictor value is this one. The input value is this one. I have the labels, I have selected the labels also, and the output range I want here itself. Okay, if you can see that this is the same x, this is the same slope and the value that I am getting here. Okay, and the p value is very large, and that is why it is not showing right now, and there is no error at all in the prediction. It is saying how relevant is your prediction. You might say that is fine, but there might be some noise also in the data. Okay, let me insert the graph, then you will understand it more better. If I need to go back. It is not resetting anyway. I will again select this thing. I will go insert, and again I will insert this scatter graph, and I will put it here. Okay. I want again why this is the normal life, but sorry, this is the ideal life. Now in the real world, the y value may be like this. It might be 12 itself, it might be 15, it might be 15, it might be 3, it might be 21, it might be it might be some other values. Okay, this might be suppose 200, 2000. Okay, take it as 30, no, for 50. So think of this example. Okay, think of this example. If I select this row and this thing, and if I again go to insert and insert the line chart, you can see the data seems quite good, but there is some variation. Okay, maybe I could add a trend line here. Okay, and here there is also a trend line I could add. So this is the expected trend line, this is the trend, but there is some noise between them. What is the value of noise? So this noise is the difference between actual value minus predicted value or ideal value. Okay, ideal value. Sorry for the spelling mistake, but I hope you understand the point. This is the real value minus this value. So this is the some noisiness. Okay, this is the some noisiness. If I perform the data analysis on this, if I perform the regression on this thing, so now my output range is this actual value. Okay, I am selecting the output value as this real world example, and this input x will be as it is. And labels I have, I don't have labels right now, so I will remove the labels. Output range I want here at the bottom. This time the coefficient and intercept value are little different. The x variable coefficient is little, and the intercept is 4. Okay. So did you get to understand what is the point of regression?
Yes, sir.
Yeah. So if I go on next step, and there could be not only one value, there could be other values also. Okay. Okay. Let me take this as linear data. Okay. I want that x1 and x3 should have higher weightage on prediction. Okay. I want this thing. I am removing this all data. So this is a linear data, and x3. What could I take the x3 value? Just the reverse order. Okay. 8, 9, 7, and I could follow the trend. 8. Sorry, the trend is 8, 7. So I should follow this trend. Okay. And the y value, this is the theoretical y value. Okay. Theoretical y value, not the actual y value. The y value I want is something like 2 times this value, 2 times this value, plus 3 times this value, plus 100. Okay. I hope this y value is 2 times x1 plus 3 times x3 plus 100. Okay. I hope no one will have any objections on it. I hope I am audible.
Yes, sir.
And this x2 is some random values. Okay. Just some random value. And there might be so this is the real life real life observations. Okay. Observe. The real life observation value is there might be some noise. Okay. The noise value I am taking some random value. Let's take the example. Here also take some uh, okay. So the real life has the theoretical values. Yes, this one. So this is the real life data set. Okay, so this is our main file, and this is our real life example of the real object file. And I want the value for 10, and what will it be? It value. Okay, I want for this value. What will be my prediction? Okay. For now, just consider these two things as irrelevant. Means this is just a theoretical data I have prepared. Okay. Yeah. So this is the thing. Let us take the x1, x3 as input variable. So I will tell you. Okay. There is one thing you already know that more data, more good model. But I will prove it a little bit wrong. Okay. The actual thing is more good data, more the good model. This is the actual code. So suppose I take the both of the this thing and perform the regression and calculate the slopes. Okay, slope by x1, slope by x2, and slope by x3, and then we will calculate the intercept, and then we will calculate the prediction. I think I should write it as slope, and this is the x1 slope, this is your x2 slope, this will be your x3 slope, and this will be your intercept, and this will be your y prediction by model. Okay, and so I will use 2-3 ways to do so. Okay, so let us perform a linear regression where I will include all variables. Okay, am I audible?
Yes, sir.
Yeah. Okay. So I will go to again the data tab, and I will go to the data analysis, and I will go to the regression. I will select my all the x ranges. So this is my x range. Then I will select all my y range, the prediction value, the real life observation, and the labels I have the data, and the output I want here itself. The x1 value you are getting as 0, x2 as this value and this value. May I take this value here itself? I think this is the x1 value. Okay, this is the x2 value. This is the x3 value. Okay, and this is the intercept value. Okay, then what will be my prediction? Can anybody tell me for this value 10? So I will write formula I have used. Yeah, 2 times x1. Sorry, the 2. Sorry, this is the 2. This is the slope times x plus this is the x2 time this x3 value plus x4 times this x3 value plus this intercept. Okay, so this will be our model prediction. Definitely I need this value, so this will be 1, and this will be some random value. Okay, maybe the random value is like this. So when I am including all the variables, I am getting this as 120, 1 to this one. But what is the expected value? The expected value is the expected value is 2 times what was the value? Yeah, 2 times the x1 plus 3 times the x3. Sorry, x3 plus 100.
So this noise we are calculating from x1, huh?
Sorry,
Noise we are calculating from x1, or are we calculating from the real life observation?
the noise is the random value. Okay.
Noise are random values. Huh? Okay.
Let me take these x2 as a randoms value, more random, and these values are not much random.
Hmm.
Maybe some small digit.
Okay. And you have to run the thing again, right?
Maybe I need to run it again. Not this 70, it should be 10. This is, I think it would work fine. Is the value has been modified? I don't think, no.
Hmm.
So can I get the refresh option? Okay, nowhere there is refresh. So okay, so I will go again the data tab, select all the regression values. I think all are good selects. Labels is there and the field is also here. So yeah. So this is the, if I include all the variables, this is the our y prediction value. And it is calculating x1 as g this value. Okay. Let us exclude the x2 and let us now do the regression. Okay. So I will go again to the data tab and go to the data analysis, go to the regression, go to the y range as this value, and x range is as this value. Okay, it is saying that input value must be contiguous in reference. So maybe I need to remove, I need to recreate the data. So I will copy this, and this.
Can you show the output of this first?
The output of first is here now.
No, the one you calculated right now, in which we got 123.2957.
This value.
See, can you show the summary output full first? I want to see something. So we are getting the values from the summary output, right? The x1, x2, the intercept here. So
Correct.
121.5 it. Huh?
Yeah, right.
So
The
that is what we are using there.
all the variables, all the x1, x2, x3. Now I will use only these variables because the most of the data is dependent on x1 and x3 only, and we will compare the both the results. So if I select this y value now, and if I select this x value, labels is there, the output range I am selecting right now here, and I will again copy the x intercept. Okay, here I will copy the x. Okay, so here I will copy the x3 intercept and in x3, and here I will copy this intercept value. Okay, and now I will calculate as this value into our x1 plus this value into our x2 plus this intercept. Uh, there is some mistake I think I am doing. I am not able to show that what I want to show. Yeah, the thing that I want to show you, I am getting correct. So can you see that there is relation between x1 and x3? Am I right? Hello.
What relation between x1 and x3? Huh?
If x1 increases, the x3 decreases by same amount.
Yes, that it is happening. You have structured it in that way. You're increasing by one, the x3 is decreasing by one.
Yeah. So are you able to recall one terminology regarding this?
Negative correlation, full, like,
So so the if you have studied the regression or stats, so there is said that the two variables should be independent, then only the regression perform well. Okay.
yes.
So here the variables are not independent, and you can see the regression output is very bad, right?
Hmm.
You can clearly see,
Yes,
right? Okay.
yes.
Yeah. So this is the one thing that you can conclude from this. Now I will copy the same thing here, and I will go to the here, and I will show you something else. So suppose now the this value is different. X3 is not dependent on x1. Then I will do the same thing again. Okay. Now x3 is some random value. Okay. But the data is dependent on x1 and x3 only. Yes. I think rerunning is correct. Here I need to send some data.
You changed something?
I just provide random.
Okay.
X2, X3 both are random. Okay, so now there are dependence between X1, X2, X3. Okay, no dependence, but Y is dependent on X1 and X3. X2 has no implementation. Now let's see the same thing, the regression. If I go here in the data type and I go to the regression value, and so I is and I said this. Okay, let me select the tables also. Output I want itself. Okay, so you can see the values are here itself. If I here predict the value that x1 times this x intercept plus x2 times this y intercept plus x3 times this x3 plus this intercept value. The value is quite related, but the thing is that this x2 is the extra variable we have right now. Now let us do the same thing and do with the two variables only. So I copy this variable, and paste the here result. Then I will go again in the data tab, go to the data analysis, go to the equation. If y this value and x is this value, and labels is there, and output I want here. And now I will calculate again the same value and this x1 plus x2 has no value, the x3 and this 3 plus intercept value. And you can see the two values how they are. I think they are very close. Oh, and here you are seeing that this value is getting more dominant, right? But the general trend is that p element value now keep close on the p value. Okay.
What happened?
Sorry, I got disconnected. Am I audible now? So I was talking about the p-value. If p-value is less than 0.05, then there is low chance of random value. So here you can see that p-value is much greater than 0. It means there is high chance. Okay. It means there is high chance that x2 is random value, not affecting prediction well. Okay. So this is represented by this value.
So please excuse me. How do you interpret p-value, sir?
Yeah, the p-value, if it is less than 0.05, then there is low chance. Means there is 5% chance that it is random. So p-value tells me that the value is random. So high the value, it means that value is higher random. So it is generally said that 5% means 0.05. Okay. Okay. So
Okay.
So
Okay.
0.05. If value is less than that, then that value is significant. Okay. So these two here it is saying that this value is too high. Okay. The x3 is more relevant. Okay. X3 the random of x3 is very less. Why? Why not x1? Why x1 is too bad? And the things that I am getting this too much different. Even x1 I am getting much higher than 0.05 because the data is not normalized. You can clearly see that these values are too high, these values are too low, right? So, and even the x1 is dependent. X1 is very relevant for my database, but p value is saying that x1 is not relevant. X1 is not affecting y. Why? Because most of the values are affected by this x3 itself. How much x1 is affecting? X1 is affecting just 2 times of 1, which will be only 2 value. And how much this x3 is affecting? It is 3 times of 45, which is 150 value. There is 2 and there is 150. Sorry, 90 plus 45, 150 will be 135. Okay. So what I am saying that 2 times 1 is 2 itself, and 3 times 45 is 135. So there is very high weightage of this. There is very high weightage of in the prediction. This value is highest weightage, no? And plus 100, which is 235. And this is 2. And the prediction value is 237. You can clearly see that x3 is affecting most of the y value. Are you able to see?
Yes, sir. Yes, sir.
X1 has very less relevant. That same thing is represented by here. But in the formula, the way we had derivated in the model that the actual model is following, where x1 and x3 both are relevant. And that is exactly why sometimes the normalization is required. Okay. So if you normalize the thing, both value will the p value will come less. The x3 has very high relevance, and that is why its value is less. x2 has least relevant. Okay. That is the one thing. The next thing is the adjusted R square. The R square. R squared is how much data is getting captured. So it is saying that 99% of trend I am able to capture. Means there is very low errors. So this is the prediction value, and this is the prediction actual value, and the difference is quite low. And that is what it is shown in the regression. So now, are you able to understand the R square and the value of P, and how the x1 and x3 are getting interpreted here?
Yes, sir.
Yeah.
Sir, one more thing. The GS6 link hasn't been shared till now, and we were actually means
The
I
GS6 is
emailed
here.
IIT Madras also regarding this.
Here GS6 is
Uh,
already.
okay, sir, can you send the link in the chat, please?
So every time a GA get released, okay, a discourse post has been created regarding that. You have to ask the question answer in this GA itself, and here is the things. And let me share the link. So from discourse you can find the link, and here is also the.
Okay, sir.
Sir, why
And the
is it not posted on the? Excuse me. Why is it not posted on the dashboard, sir? As it used to be.
I don't know. Maybe it is
I-
taking time.
Okay. Okay. Sir. Thank you. Thank you.
So it is, and also the problem is no. Every time, every term, the unanswer change the questions. So just 2-3 days ago, the question has been changed. So maybe a portion of the portal is too much hectic for them, and that is why one discourse post is created. Also, the thing is that all the GA you can access from the URL itself. If you type the GS7, you can access the GS7 itself. Problem with GS7 is that this is not right, but other GAs also you can access. But the problem is that that particular GA might be changed. Okay, so start solving GA only after a Discord post has been created, because the GA question got changed. Okay, get
Okay,
the
sir.
point?
Thank you. Yeah. Yeah. Thank you, sir.
Yeah. So other, I think most of the question now you can do this correlation. You can do. This is also calculating of the correlation again. And one more thing I forgot. If you want to calculate a correlation between intermediate, I think I have covered. No? I have put that. Other thing is the prediction value. This is how you have to predict. The same prediction that I did here, you can use the forecast method. Okay, forecast. Okay, the forecast, with the help of forecast. Let me show you here in the simple thing. Yeah, here. Okay, if I use the forecast, FORCA. Okay, here let us use the forecast method. Okay, I will use this forecast method. And here I will provide the value of x. This is the value I want to predict. Okay, the known values of y, these are the known values of y, and the known values of x. Okay, this automatically calculate everything and calculate the value. Automatically calculate this x value, intercept value, and multiply it and give it back. Okay, is that fine?
So it is as good as that formula regression, is it?
Yeah, the same formula. That may got you the means that might cost you a time, but this is the fast way. It not only calculate the value and it multiply and directly give you prediction for that.
Okay.
So
thank you.
how normally you give the prediction? You first calculate the regression, then take the variable name, multiply with the x value, then add the intercept. Right? This is the intercept, and hit enter, and then you get the predicted value. So there are two steps, and this forecast method transform your two step to one step. Okay. Okay, the p-value part is clear, the correlation part is clear. Higher value means good prediction. Okay, and then there is the correlation value. The value is between -1 to 1 and 0. 0 means no relation. 1 means one increases, another increases, one decreases, and another decreases. And here the reverse thing. Okay, this is the correlation, this is the p-value, and this is the r square. Okay, now let us come to the next point. What is the next point? I think maybe I need to show some other things. Okay, one was the distance calculations. Yeah, the IQR, the how to calculate the this part. Okay, so what I am telling is the quartile part. The first thing is the quartile. So this is the data. Okay, so you want to find the outlier from this data. So first you calculate the first quartile, which is known as 25 percentile. Okay, means where the 25% of the data lies. Then 50 percentile, where the 50% of data lies. It is the median value. Okay, this is the median value. And next thing is the third quartile. Okay, and next one is the fourth quartile, means 100% of the values. So what do I mean? Maybe I should show one diagram. So box plot quartile. I think I have already done it. Yeah. Yeah, here it is done. Okay, so maybe your data is like this. Okay, this is the value 10, this is the value 100. Your minimum value is 10 and the maximum value is 100. Okay, some data are like this 10, 11, 12, then there are 100 data, but most of the data are here like 59, 80, 90, 60, 65, 67. Okay, so most of the data are concentrated here itself. Okay, so since most of the data are sorry, yeah, suppose this is 1, 2, 3, 4, 5. 5 data are here, 5 data are here. So this is the 25 percentile of data, means 25% of data here, 25% of data is here, and this is the maximum percentage of data here. I think the Q4 is this one. I think this is the Q4. This is Q1, this is Q2, this is Q3, this is Q4. Okay. So this is not the 25 percentile, but this is the main percentile which we got the data. Most of the data are here. The 50 percentile are also here. So what is the outlier? The data which is from the median. Okay. If this data is outlier and this data is outlier. Let me show you in the more good diagram. I am not able to draw the diagram. Outlier and quartile in box plot. Yeah, this is the. Yeah, this one is a good image where everything is present. So this is your interquartile. This is your all data. Okay, from outlier to this outlier. Okay, this is the all the data, and this much data is your 25 percentile, and this much data is the 75 percentile. So 50% of your data lies here, and other 50% of data is distributed here and here. So we count that outliers is from this range and this IQR range. Okay, we are creating this. Okay, so this is the IQR range, and what what the outlier agenda say that if most of the data are here, okay, then after that, after this point, only consider 1.5 times. Just make it little board and add it here. Okay. So this is 1.5 times this IQR. Okay. All the data going forward are getting registered, and we say that they are outliers. So how to calculate it? Just calculate the first quartile, pass the range. I have passed this range, and calculate just pass it here 1. You will get the first quartile. Second quartile, just pass the value 2 here, and you will get the second quartile. Okay, for the same range. And similarly, third, fourth thing. Then what will be IQR value? This IQR value is exactly just this Q3, the third quartile minus the first quartile. Okay, then you need to calculate the lower bound of the IQR. So you just calculate the lower bound, the first quartile value minus 1.5 times the IQR range. Okay, the same data I am getting, and if you add it, you will get the upper bound. And then you can count with the help of count function that how many data are outliers. This is the count function, which tells that the data is less than that all the data which are less than the lower bound are getting counted, plus all the data which are more than the upper bound are getting counted. For this data, there is only one data which is getting counted, which is getting as outlier. Which one is this? I think this data. This data is less than the lower bound, 98 point. No, sorry. Which one is the district? $29. I think I have changed some values, and that is why the values are different. Yeah, this one is this data, the upper bound. It is greater than this upper bound. Okay. So that is why it is counted as outlier. I hope you get the point, and you can do this outlier question, the counting of how many outliers are there. Okay. Let us move to the more relevant thing, and let us study one important thing which is known as Dijkstra algorithm. Okay, so Dijkstra algorithm find the shortest path. Okay. So just wait a moment. Yeah. So Dijkstra find the shortest path from one point to any other point. Okay. So what does it do? No? Suppose this is the 0 and the cost of going from 0 to 1 is 10. So it tracks the node and it tracks the visited value and it tracks the cost. Okay, the cost or you can say the distance. And initially it says that 1, 2, 3, 4, 5, 6, 7, 8. I think the 6 value. Okay. What it initially said that everything is unreachable from me. Every node is unreachable. And unreachable from me, and I have not reached. This is reach or visited or reached. So everyone passed it into my time. Then what it does do? It starts from the it starts from the starting point. Okay, so this node are getting 0 cost, and this 0 node has been visited. Okay, so 0 is also. Okay, so 0 is get visited, and this cost has 0. And now the things comes. What the thing comes? Uh, uh, explore the least cost node. That is the thing, and update the other values. So this part you have to repeat again and again. Okay, maybe the color is very bad. That is correct. We have to explore the least cost node and update the cost. And this part have to be repeated, and this all thing has to be done in non-visited. Okay, the non-visited. Okay, so this 0 has been visited, so I am not to use that. So I pick the least one, this one, and I visit it. I visited it. Now I will update the cost from this node. So from this node, this cost will be updated to 10 because this is costing 10 unit, and this cost will be updated to 80. Okay. Okay. Now I will the cost has been updated. Now I will again explore the least cost node. The least cost node is now 10. So I will explore this cost node and update the cost. So this cost will be getting 10 plus 20, which is 30. And this 80 cost will be reduced now to 10 plus 6 is 60. So this 60 cost will be reduced to 60. And the forecast has been updated to. Okay. Now I will explore again the non-visited node and pick the list path traveled node. I will pick the second node, mark it through, and then I will explore it. The 2 has been explored, and this cost has been updated to 16 plus 70, which is 86. Okay. Now which node has to be chosen? This one. Okay, because this is the least cost. So the fourth one we will choose and update the both the cost, which is 30 plus 50, 80, and 30 plus 5, which is 35. Now I will visit the least expected node again. This is a 35 because least distance. And now I will update the cost from 35 plus 10. No, there is no path from here to here. So, so I will not update it. Then the last part is this one. So the cost of going from 0 point to 1, 0 to 2, 0 to 3, 0 to 4, okay, 0 to 1, 2, 3, 4, 5, 6 is this. From 0 to 0, what is the cost? 0 itself. From 0 to 1, 10, 16, 36, 30, 80, and 35. So it means if you want to go from 0 to 6, at least you have to cover the 35 distance. And that is all about the Dijkstra algorithm. Okay. Okay. The next important thing that I want to cover is the this question, which is pretty good. In the if you go to the this one question, okay, this is the Dijkstra algorithm that I just covered, the last question. Now coming to this part, okay. So what it does do, what is this formula means? Let me clarify you. What does this formula is calculating? Okay. So what is this doing? This first line, if you can clearly see the first line, it is just multiplying 2 into the radius. And this A sign, what does A sign means? A sign means sine inverse. Okay. So it is calculating A sign of this whole formula, and then it is then it is calculating the square root of all the things. What are all the things are here? The all the things it is saying that take the uh, take the sine latitude 2 and latitude 1. Okay,
I think
it is
your
saying
voice is breaking a lot.
is it now okay?
Slightly better.
Okay. So what it is saying that this is saying that take the sine value of latitude divided by 2, and this value has to be in radian. So that is why these all the calculation pi 180 has been done. Okay. Okay. And that value you have to square, then plus cos of the latitude of first point in the radian form. Take the cos and then add the cos value of latitude 2, and then take again sine square of this value, your longitude by 2. Okay. So this is the formula which is it is saying, and the R value you can directly substitute it here as 3959. Okay. So if you the same formula, uh, if you try to do, you can do in the shorter form. This formula you can write it like this: sine of radian of that particular latitude minus that particular latitude divided by 2. Okay. And then you can take the square of it. So there is radian function which is already there in Excel that you can use instead of doing this pi multiplication divided by 180. So this one tip that you can use. And so what does question is saying that, so what does it mean? What we are doing here, that suppose I have given latitude and longitude. So latitudes and longitude are here, and there is also a latitude and longitude. So what is distance between them? So this distance is getting calculated by this formula. So just use this formula and find out the distance from all the points. So there will be one form. So how the data is, I will not show the solution code. So here the latitude is given, longitude is given, and one point is given. So this is the list of data that we will get. But there is one point given, means so whose latitude is given and longitude is given. Okay. So pick this latitude longitude instead of this latitude and longitude. And for each data point, for these two data points, calculate the distance. For these two data points, calculate the distance. For these two data points, calculate the distance. Okay. And after doing all the calculation, just find the minimum distance. And that is the question. And this is how you can easily do this question also. Any doubts so far?
This question is just to calculate the distance given the latitude and longitude and calculate the minimum value. Huh? Only this.
Yeah, right. Yeah. So most of the question I have covered. I think all the first these questions you can. I think I have opened the GA5. Yeah. So most of the question you can do right now, and these two questions also you can do right now. So this SQL part will be covered by Jivraj in tomorrow session. Okay. Any doubts
Okay.
till now?
Is the GS6 link which we have right now, is that something we can attempt, or will it be changed?
No, no, no. This is live on Discourse, no. So you can attempt it right now.
Okay. Okay.
Even all the GA question doesn't change. Many of the questions are repeated from previous term, but some questions get changed. Since it is published on the Discourse, so you need to attempt right now. So do it by today only and tomorrow only. Complete it since there is quiz also.
We do not have quiz for TDS, no?
Yeah, no quiz. The ROE is on 20 July. Yeah, correct. So ROE going to be tough. We start working on it. Okay. Okay, then. Any doubts?
So the ROE will have syllabus of up to 6th week or the week 5 only?
For ROE, right now I will not able to answer. The ROE questions are yet to be decided, and the syllabus I think will be decided. Will be conveyed by you till 15th, 14 or 15 days. Okay. Maybe on 11 it will get in live because Anand sir is on leave, so there is a small delay in that.
Okay.
So
Sir, will there be any special TA classes for that, sir, for ROE?
right now it is not scheduled, but yeah, there might be some TA session for ROE. Sir has means the question are not decided yet. Sir has not decided, and the topics also we don't know. So there
So the
might be some
questions will
TA
be,
session. I am not sure.
so the questions will be more difficult than the GA questions.
It will be almost similar to GA question. If you have done all the GA, then I think you will be sorted out 50% of the thing.
I see. Okay, sir.
So in tools and data science, here the dates are there. 20 July. Okay. And it will means if you ask this question that how the GA question will be around 14th 15th, then we will able to answer that what the topics you should prepare and what the things you should go. Before that, I also have no idea that what type of question might come. Means there might be chance that whole ROE might be a completely different from the GA itself. But the previous term, the ROE was from the GA. Okay. Maybe 70% GA, the same questions you might get, but the data will be different. But there might be a surprise for you also. So I cannot say anything about the ROE.
Perhaps you do not know, no? The questions are not set.
Yeah, but I don't know. And from the team, I got to know that the ROE, the what type of question will be, means are yet to be decided. Anand sir is on the leave right now, and he will decide that what will be the content inside the ROE. In the previous term, the most of the questions were from the ROE itself. So I can answer based on only previous term data right now.
Okay, sir.
And the difficulty level is that because the time is very less, around 45 minutes, and you will have 5 to 10 questions. And there is also coming to be project 2, which are going to be very difficult. Okay.
Okay, the draft is out for project 2.
Huh?
For the project 2.